Questions 1 through 10 on the 2021 Grade 10 AMC 10B. How many integer values of x satisfy the absolute value of x is less than 3 pi? Well, 3 times pi, if you use 3.14, will be 9.42. So we want a number that's less than 9.42. But since we're taking the absolute value, it's also got to be greater than negative 9.42. So any integer in that range will suffice. So that's negative 9, negative 8, and so on, till negative 1, then the 0, and then 1, and then 2, all the way up until 8 and 9. So we have 9 integers here. Don't forget the 0, that's 1 integer, and these 9. So 9 plus 1 plus 9, that is 19. Number 1 is D. What is the value of this expression? Well, notice we are taking the square and then we're taking the square root. So those cancel each other, but only if what is inside is positive. So the first one is clearly positive. So if you took the square and then took the square root, you would just get what that is inside the bracket. But this one you have to be careful. This is a tricky question because 3 minus 2 root 3 is negative. It's less than 0. So when you take the square root, you'd make it positive, and then when you take the square, you'd make it positive, and then when you take the square root, it would still be positive. So we have to use the positive version of that, which would be negative 3 minus 2 root 3. So when you do that, it would become 2 root 3 minus 3, and that is a positive number. Root 3 is about 1.7. If you times it by 2, it would be 3.4. 3.4 minus 3 is 0.4, which is obviously greater than 0. So that's why this is tricky. The rest is pretty straightforward now. 2 root 3 minus 3 plus 3 plus 2 root 3. And that looks like it's just 4 root 3. So number 2, the answer is D. In an after-school program for juniors and seniors, there is a debate team with an equal number of students from each class on the team. Among the 28 students in the program, 25 juniors, 25% are juniors, and 10% are seniors are on the debate team. How many juniors are in the program? We have 28 students, and some are juniors, some are seniors. So the juniors divided by 4, which is 25%, is equal to the seniors divided by 10, which is 10%. So we just have to kind of plug and play here. The number of seniors is divisible by 10, so let's say the number of seniors is 10. If you put that in here, we would calculate that J is 4. The number of seniors plus the number of juniors must equal 28. But in this case, it only equals 14, so this can't be the right answer. All right, no problem. Let's try 20, the next number that is divisible by 10. If S is 20, J would be 8. S plus J is indeed 28. So this is the correct. And what do they want? How many juniors are in the program? Well, the number of juniors is 8. So number 3, the answer is C. At a math contest, 57 students are wearing blue shirts, 75 are wearing yellow shirts. 132 students are assigned into 66 pairs. In exactly 23 of these pairs, both students are wearing blue shirts. And how many pairs are both students wearing yellow shirts? Well, we have 57 and 75. That's a total of 132. These 57 are wearing blue. These 75 are wearing yellow. So we have 132 students, and that is 66 pairs. Now, these pairs are split up into a few categories. So the first category is 23 pairs, and that's obviously 46 students. And all of these students are wearing blue. So these are the blue pairs. So all 46 are wearing blue. Now there's 57 in total that wear blue. 46 students are here. So that must mean 57 minus 46, which is 11. Those 11 students would go here. So we have 11 students here that are wearing blue. And they have to be paired with 11 students that are wearing yellow. So that's 22 students, and that's 11 pairs. So I have 23 pairs here, 11 pairs here. So 66 minus 23 minus 11 would give me the remaining pairs, and that is 32 pairs. So that's how many pairs are remaining, and that's 64 students. Now the blue t-shirts are all used up, so we only have yellow. We used 11 here, so 75 minus 11 is 64. So 64 students go here, and all 64 will be wearing yellow, and that comprises 32 pairs. So, and how many pairs are both students wearing yellow shirts? Well, that's 32 pairs. So number 4, the answer is B. The ages of Joni's 4 cousins are distinct single-digit positive integers. 2 of the cousins' ages multiplied together give 24, while the other 2 multiplied to give 30. What is the sum of the ages of Joni's 4 cousins? Let those ages be A, B, C, and D, and therefore A times B is equal to 24. And then C times D is equal to 30. So you just fiddle around with this. What 2 numbers multiplied together give you 24 that are single digits? Well, 3 and 8 would work. And then similarly, what 2 numbers would give 30? 5 and 6 would work. Now, let's see, are they all distinct? Yes, they are. 3, 8, 5, and 6 are all distinct. And are they all single digit? Yes, they are. So now we just have to add them up to get the sum. 3 plus 8 plus 5 plus 6, and that is 22. So number 5, the answer is B. Mrs. Blackwell gives an exam to 2 classes. The mean of the scores of the students in the morning class is 84, and the afternoon's class's mean is 70. The ratio of the number of students in the morning class to the number of students in the afternoon class is 3/4. What is the mean of the scores of all the students? So we'll say 3x and 4x are the number of students in the 2 classes. So the sum of the entire scores of the first class would be the number of students times the mean, which is 84. And over here, the sum of the scores would be 4x times 70. And then to get the total average of all the scores, you'd add them and divide by the total number of students, which is 3x plus 4x. And there you go, that's the math. The x's cancel, so all you're left with is 3 times 84, which is 252, and then 4 times 70, which is 280, and then you divide by 7. And that gives you 76. So number 6, the answer is C. In a plane, 4 circles with radii 1, 3, 5, and 7 are tangent to the line L at some same point A, but they may be on the either side of L. Region S consists of all the points that lie inside exactly one of the 4 circles. What is the maximum possible area of region S? Well, let's draw the diagram and see what we can get, what kind of a shape. So after fiddling around with this, I conclude that the maximum will be obtained as follows. So we have to draw it in like this. So we can obtain the maximum if we use that and we use these areas. And this question, the wording is kind of bad, to be honest, because exactly one of the 4 circles made me think, okay, just one, so just choose that one. And therefore, the area would be pi r squared. Since the radius is 7, that's 49 pi. But 49 pi is not one of the answers. So that made me think that we also have to include the other side. And as long as the points are inside exactly one circle, it would be sufficient. So here, this would be inside 2 circles, right? And this would be inside 3 circles. So these blue lines are only inside 1 circle. So maybe they could have put in more than 1 circle can be used or something like that, because this question, the wording is terrible. So we have to figure out this region now. So that's going to be the area of the circle with radius 5, so pi 5 squared, minus the circle that has a radius of 3. So that's going to be pi 3 squared. So that's 25 minus 9, 16 pi. So then we just have to add these two guys, and that's 65 pi. And therefore, number 7, that would be D. Mr. Zhao places all the integers from 1 to 225 into a 15 by 15 grid. He places 1 in the middle square, 8th row and 8th column, and places the other numbers 1 by 1 clockwise as shown in part of the diagram below. What is the sum of the greatest number and the least number that appear in the second row from the top? In these types of questions, always look for a pattern. I've done enough to kind of recognize the pattern that these diagonals look like all perfect squares, and they are. So starting from the center, it would be 1, and then 9, and then 25, and then that next one would be 7 squared, 49, and then 9 squared, 81, 11 squared, 121, 13 squared, 169, and then finally 15 squared, which is 225, and that's the maximum number since that is the upper limit. And then now we have to figure out, okay, which row do they want? They want the second row from the top. So that's going to be the row that contains the 169. Okay, I think this is enough for us to understand how this works. If I want to get to 25, it looks like I'm going to the right consecutive numbers. So that means that I've got to go this way to get to 169. And this was 5 numbers, and 5 is the square root of 25. So I've got to go the square root of 169, which is 13 numbers. So that means I must start at 157. So 157, 158, all the way till 168. And that is indeed 13 numbers. Okay, so that part is fine. But I've still got one number here and one number here. So I've got to figure that out. All right, well, if you look just at this one, it looks like it kind of keeps going like that, right? So that means that this number here is the next number after 25. So that means this number here has got to be the next number after 169. So that's got to be 170. Okay, so I just have to figure out one more number, and that's this one right here. So that one I'm going to look at it like this number. How do I get to that number? Well, you're not going one below 21 because the 20 is here. So how do you get to that number? It looks to me that this kind of goes like this. You see what I mean? So if I got that number, then I can go backward. And I do have that number. It's 225. Okay? So if I work backward, the top row is going to be 15 numbers because all rows have 15 numbers. So it looks like this starts at 211. And then 212, all the way up until 225, right? So this number here would be one below 211, and that's 210. So there we go. Therefore, in that second row, the greatest number is 210, and the smallest number, least number, is 157. So the sum of those numbers looks like, to me, 763, 367. And therefore, number 8, the answer is A. Point AB in the xy plane is first rotated counterclockwise by 90 around the point 15 and then reflected about the line y equals negative x. The image of P after these two transformations is negative 6.3. What is B minus A? Well, let's figure this out. So let's draw a little coordinate plane like that. And let's see what happens. So the first thing I'd like to do is put in that 0.15. So approximately 1, 2, 3, 4, 5. So there's 1, 5. And then let's draw in that line y equals negative x. So that's just straight down, right? Y equals negative x like that, chopping it in half. And then where are we going next here? The image after these two transformations is negative 6.3. So 1, 2, 3, 4, 5, 6. So negative 6.3. So approximately here. Okay. So that resulted there after it was reflected in this y equals negative x. So let's go backwards and figure out where it would be. It would probably be here, approximately. Approximately here, right? Because it's going to reflect just like a mirror reflection. And therefore, this point, if it's negative 6.3, this point up here would be negative 3, 6. Negative 3, 6, like that. And you can sort of deduce that just from the graph itself, since that is 6 and this is 3. Okay, now we got to get into the final thing, which is we have to reflect some point about 1,5, 90 degrees. So we had to reflect it like that. Okay, so I'm not sure where it is, but somewhere approximately here. I'm trying to get a 90 degree here, and I think that's pretty good. So there was some point here that was our original point, PAB, and it was reflected 90 degrees about this point in order to get here, and then that was reflected to get to there. So I've got to figure out PAB. Well, the good news is that this line is perpendicular to that line, and therefore that means that the slopes of those two lines will be negative reciprocals. And if you remember negative reciprocal, the product of two negative reciprocals is negative 1. So for example, if you have one negative reciprocal is a half, the negative reciprocal of that would be negative 2, because if you multiply them together, it gives negative 1. So the slope of this line right here, that can be easily calculated, 6 minus 1, and then negative 3 minus 1. And then we have to multiply that by the slope of the other guy right here, this line. That would be a b minus 5 over a minus 1. And because they're negative reciprocals, that product will be 1. Okay, so this looks like, that should have been 6 minus 5. Sorry about that. 6 minus 5. So that's going to be 1 over negative 4 times b minus 5 over a minus 1, negative 1. So that means b minus 5 is going to be minus 4 times a minus 1 times negative 1. So b minus 5 is equal to 4a minus 4. And therefore b is equal to 4a plus 1. And then b minus a, which is what they want, looks like b minus a, 4a plus 1 minus a, which is 3a plus 1. And even if you don't want to figure out the values of a and b, you can say, well, this is some multiple of 3 plus 1. And a obviously is greater than 0, right? Because it's somewhere here. So a, let's say it's 1, then this would be 4, but 4 is not one of the answer choices. If a is 2, this is going to be 7. So there we go. Now, if you didn't want to work it that way, you can figure out the values, actual values of a and b by just making a little right triangle like that. And since this was the slope of this line, the slope of this line will be the negative reciprocal, which would be 4, positive 4. So that slope is positive 4. So that basically means the rise over the run is 4. So if we, for example, went across 1 unit, we'd have to go up by 4 units. And that's the only way you'd get a slope of 4. So if we do go across 1 unit and go to here, that'd be going to 0.2. And then if we go up 4 units from here, that'd be going up to 9. So this is actually 2, 9. And again, b minus a would be the same. b minus a would be 9 minus 2, which is 7. So either way, the answer is 7. That would be D for number 9. An inverted cone with base radius 12 and height 18 is full of water. The water is poured into a tall cylinder whose horizontal base has a radius of 24. What is the height in centimeters of the water in the cylinder? Well, the volume of a cone is 1/3 pi r squared times height. The volume of a cylinder is pi r squared times the height. So they're telling me that this volume is 1/3, the radius is 12, so 12 squared, and the height is 18. So that means this volume is 864 pi. This volume over here, which is the cone, this was the cone, and this is the cylinder. This one, did they give us any? Yeah, they give us just the radius, so 24 squared, and I guess the height is what we have to figure out. Okay, but this is equivalent to that. They've told us that in the question. The water is poured into a tall cylinder whose horizontal base, right? So, the height of the water we can figure out by setting this equal to that, because it's the same amount of water. So 864 pi is equal to pi 24 squared times height. So that basically means that we have 864 over 24 squared. And when you do that math, you get h is equal to 1.5. Number 10, the answer is A.